Let's get started. So the first step is always to look for a GCF.
Yes.
From there, if we have 4 terms, we are going to group. We talked about grouping again on Friday when I went over your homework with you. Remember I did a grouping problem with you guys?
Yeah.
If it has 3 terms, you're going to do guess and check, which is what we've been doing for the last 3 days. Today, we are going to learn our 2 terms. If you have 2 terms, you're going to use difference of squares. So, difference of squares is when you have 2 terms. What does the word difference mean?
When they're not
Minus.
the same.
Subtraction. Squares are perfect squares. So, somebody please tell me a perfect square. Raise your hand and tell me a perfect square.
7
Not both of those.
It has 4 sides.
Okay. Number 49 is a perfect square. What's another perfect square? Raise your hand. 64 is another one. Yes, Blaine. 64, yes.
81.
81. We are way up there with these. Yes.
Wait,
Go
what
ahead,
is
Connor.
it? What is it?
The same number times the same number makes the perfect square.
Oh, 36.
36, yes.
144.
144. So, Connor just asked a fantastic question. He's like, what makes a perfect square, essentially, is what you asked? It's the same number times the same number. So, those are perfect squares. 4, 9, 16, 25. You guys missed those ones. You went right up to the big ones. So, those, 3 and 3 is 9. So, 9 is the perfect square. Yes. So, that is a perfect square. Please stop talking. Difference means you are subtracting the binomial, so it must be subtraction. We need to talk about perfect squares with variables. So what are perfect squares when it comes to variables? Is x to the first a perfect square? Can the same thing times the same thing be x to the first?
Yes.
What?
X times that.
X times.
You fool.
So this is not a perfect square, but is x squared?
Yeah.
That's because you can do x times x. How about x to the third? Can you do the same thing times the same thing?
No.
No.
How about x to the fourth?
Yes. Even C.
So what do you notice about the exponents on a variable?
They're even though.
They have to be even. So if we're talking about a variable, for it to be a perfect square, it needs to be even. Very good, Connor, for picking that up so quickly.
Oh, you're so smart.
It is important we understand what a perfect square as a number and a perfect square as a variable is in order to do this. Your last step, no matter what, when you get here, you have one more step, and that last step is to look for a difference of squares. So look for a difference of squares. So after you do it, you have to check for a difference of squares more than once. That is your very last step. This would be step 3. This would be step 2. Okay, so let's get started on what it means for steps for difference of squares, and then we'll do some.
Just not okay.
We are going to be factoring completely tomorrow. We will be reviewing on the block, and you will be testing on Friday. Stop talking. If you are not going to be here Friday, you need to let me know, because you will do worse on the test if you wait till after spring break than if you try to take it before, because you will forget everything. Do you understand me? I don't want you to do worse. Quadratics.
What?
What is that?
They're parabolas that makes a U shape on the graph.
What is what?
Okay, steps for factoring perfect squares. Are the 2 terms perfect squares, and is there a subtraction sign in between them? If so, the binomial can be factored as the difference of 2 perfect squares. A squared minus b is you take the first and the last term, whatever multiplies a times a, and b times b, and then the signs are different signs. That is the steps for difference of squares. It's pretty straightforward and easy once you pick up on it. Basically, what you're trying to do is get a 0 in the middle. You're trying to get a 0 in the middle term for your bx term, that middle term, okay? So let's talk about this. So technically, if we were thinking like this was a trinomial, this has a 0x in the middle. So we are trying to get 0. We're trying to get our terms in the middle to cancel out. Do you understand that?
Sure.
We are trying to get a 0 in the middle. Do you see how there's nothing, no x term here?
Yes.
Okay, hurry up, please. So the factors for x squared are x times x.
Yes.
The factors for 81 are 1 and 81.
Where does the 0 come from?
I put it there because there's no bx term. I'm trying just to show you guys something. We'll do that without that in a little bit, but I want to show you guys some things first. 3 and 27.
Like you were the weirdest thing.
Is 6 doesn't go into that, right? No. Okay. So those are your options. We're trying to get 0 in the middle. Which one of these terms looks like it will give you 0 in the middle? So this is like the third time I've said this, just to remind you guys. Do you guys see how there's no, it's not x squared plus whatever x minus 81? Do you see how there's no x term here? So that means we're trying to get 0 in the middle. That's what that means. So if we try that, we need one of each sign, because this is a negative, right? One of each sign. So I have x plus 9, x minus 9. So that's x squared minus 9x plus 9x minus 81. What happens to negative 9x plus 9x? Did we get back to the original? Yes. If you can recognize these are perfect squares, this pattern will happen every single time. If you can recognize that x squared is a perfect square and 81 is a perfect square, you do not have to think about it like this at all. Why are you talking? Stop. Again, if you can recognize that x squared is a perfect square and 81 is a perfect square, meaning the same thing times the same thing multiplies to get those, you don't even have to think about this as canceling the middle term, because it will always take the split of those and have opposite signs in between. Yes?
You switch the sign on the answer.
It doesn't matter which way you write it.
Okay.
Yeah.
Still.
It's okay, I've done, because there's no bx term. Usually, like, when we do this, it's like 2x squared plus 3x minus 1 when we're dealing with trinomials. Do you see how we don't have this x term in there? So that means there's like 0 in the middle. Does that make more sense now? All right. How can we multiply to get 16x squared? And notice we have a 0 term there. I'm not going to do this every single time. I'm just going to do this for the first couple here. How can I multiply to get 16?
8.
Riley.
1 and 1x and 16x.
Good. What else can I do?
8.
8 and 2. And how do you multiply to make 1?
1.
1.
What do we know about our sign since our n sign is negative?
1's negative 1.
You need one of each. Which set of those numbers do you think will get that middle term to cancel out? The same things. Well, let's just try this. Let's try 8x and 2x real quick. I know it's not going to work, and you're like, why is she doing this and torturing us? But this is how it goes. So that's 16x squared minus 8x plus 2x minus 1 is negative 6x. So does that really help us? Even if we switch the sign, does it help us? No, but you guys had said probably 4x minus 1 and 4x plus 1, right? What happens with 4x minus 4x? Do we have what we want in the middle then?
Yeah.
Does this look like our original? Okay, so first of all, was there a GCF at all in our answer or in our original? Nope, we couldn't take anything out. Okay, so let's look at some similarities we notice about these first two. What are some similarities you guys might notice here
They both have,
about these first two?
they both have the same, like the first term in each one is not.
Like the x squared term? Is that what you're saying?
I don't know what it's called. Like, you know, like in the first one it's x minus 9.
Oh,
It's like-
okay.
Yeah.
So something with an x there. Okay, yeah. What else do you guys notice about the beginning and end terms here? the front term and the front term are the same. The back term and the back term are the same, but with opposite sides, right? This is because this is a difference of perfect squares. Look at that first one for me. Is x squared a perfect square? Guys, please listen. Is x squared a perfect square?
Yeah.
Yes, because x times x. Is 81 a perfect square? Yes, because of 9 times 9. Do you see those are the numbers we used here? Is 16 a perfect square? Yeah, because of 4 times 4, right? Is x squared a perfect square? Yes, because of x times x. Is 1 a perfect square?
No,
Yes, because 1 times 1 is 1. So you'll notice that all of our pieces here are perfect squares. So let's try number 3. Number 3, is there a GCF?
No.
90.
No, there is not. But you should notice that it's a binomial, meaning it's 2 terms. So we need to check to see if it's a difference of perfect squares. Is this a difference of squares? Is 4 a perfect square?
Yeah.
What makes 4? 2 times 2 makes 4. Is x squared a perfect square?
Yes.
What times what?
X times X.
And how about y?
Y
Yeah.
times Y.
Okay, lastly, is 9 a perfect square?
Yeah.
Then we have to check it's a difference. Is this a difference?
Yeah.
Yes, that means we get to have one of each sign, right? So with that being said, who thinks they know what's going to be in our parentheses then? Tanari?
2xy plus 3, then 2xy.
Notice we're missing a middle term here, so we are trying to get 0 in the middle still. Now, Tanari has the same thing in the front with the 2xy, the same thing in the back with the 3's, but they're opposite signs, right? That's what we said the pattern of a difference of square looks like. So let's distribute this and see if that's right. 2xy times 2xy is 4x squared y squared. 2 times negative 3 is negative 6xy plus 6xy minus 9. Can we cancel out negative 6xy and positive 6xy? Yeah, does that get us back to that original then?
Yes.
So our answer is
Yes.
2xy plus 3 times 2xy minus 3. Okay, I want you guys to try that next one, just the next one on your own real quick.
It's too hard. I give up.
So, 5 times 5 makes 25 a perfect square, and r times r makes r squared a perfect square, right? 7 times 7 makes 49 a perfect square, but s times s makes that. So we know the sign should be opposite, so you should have gotten 5r minus 7s and 5r plus 7s. When you're going to check this, do not forget your middle terms. So that's 35rs minus 35rs, which does go away. Some of you guys are not distributing those middle terms, which is an issue, because that may not cancel out. It does not matter which one has the plus and which one has the minus. Order does not matter. It's commutative. So questions on that one before we continue on? All right. So factor each binomial. First, look for a GCF. Is there a GCF in 3n squared minus 27? What?
3.
So we can divide out a 3. So I have n squared minus 9. So we now need to ask ourselves, do we have a difference of perfect squares there? Is n squared a perfect square?
Yeah.
Yeah, what times what?
10 times 10.
How about 9?
3 times 3.
Is that a sign? Is that sign? Meaning you use one of each. Does subtraction mean difference? Yes. So we have 3 times n minus 3 times n plus 3. Why do I have that 3 out front?
Because that's your.
Yeah.
So if I look at my middle terms, does 3n minus 3n go away?
Yeah.
Yep, so that is my answer there. So if you're looking at this, is where we need to look at our binomials. Please stop talking. Look at our binomials. Are these perfect squares? Is that a perfect square? No, so you can't keep going. Is this a perfect square? No, so you can't keep going. So we're going to go down to this one. And then we are going to do a few of the other ones on this page, and then I'll have to try some. So, is there a GCF in 9m squared plus 121? No, but 9 is a perfect square, right?
Yeah.
And m squared is a perfect square. Is 121 a perfect square?
Yeah.
Okay, a positive means we're going to use what sign? Or a. Okay, so we also have other options here, right? Okay, if I do 3m plus 11 and 3m plus 11. First of all, does it make sense to do 1 and 121? No, why doesn't it make sense to do 1 and 121? Are those really going to cancel out in the middle probably? No, so let's try this. If I do my middle terms, I get 33m plus 33m. So that is 66m. Did that cancel out?
No.
If I change the signs, is that going to matter? No, that would just make it negative 66m. Does that matter? Can I do one of each sign? Am I allowed to in this case?
No.
Why not?
Well, it's not a negative.
It's not a negative 121. We want a positive 121 in the end. Do you see that? So is that going to matter for us then? So let me just try 9m plus 11 and 9m, not 9m, sorry, and 1m plus 11. Well, that's 99m plus 1m. Is that helpful? What do you guys think the answer to this one is? It's prime. You cannot factor this one. This is not a difference. It's perfect squares, but do you guys see that this is not a difference?
Yeah.
So is there any way to get it to cancel out the middle if we don't have one positive, one negative?
Oh.
So we can't do it that way. So that one is prime. Okay, our front term here is negative. Do we want our front term to be negative? No, so we're going to take out our GCF as a negative. What is our GCF that we're taking out? Yeah, the one that I just wrote down. So I have x squared minus 64y squared. Why is your phone in your hand? Put it down.
No, I don't see one.
There's a clock right there.
I like this.
Is x squared a perfect square?
Yeah.
Yes, x times x. Is 64 a perfect square?
Yeah.
Is y a perfect square?
Well, y squared.
I meant y squared, yes. Is our sign a subtraction sign? -2. That's it. Jayla, how is this one going to factor then? Don't just look, you're fine. So we want the middle term to cancel out. Do you see how there's no bx term? So what do the front ones need to be? What do my front numbers need to be? X and x. And then what does my back need to be? And what are my signs? So we distribute, that's negative 8xy plus 8xy. Will those cancel out, guys?
Yep.
What needs to be a part of my answer?
-2.
That -2. Don't worry too much about the fractions there, guys. Is 9 a perfect square?
Yes.
Yeah.
So what do you think is going to make it 1/9 a perfect square? What would you multiply together then? 1/3 times 1/3.
It's not a perfect square, it's a fraction.
Still is a perfect square. It can multiply the same thing times the same thing. What about 1/4?
A half.
Do we have one of each sign?
Yes.
Yeah.
So Josh, how would I write up my answer then?
1/3 x plus 1/2, and then 1/3 x minus 1/2.
So we distribute those middle terms. As long as it, I guess, as long as the fraction is, as long as it can be written as a fraction, I guess. But we're not gonna look at it that way. So those cancel out. So that is our answer there.
Yeah.
I'm so proud of you, Doc.
Okay, let's look at the next slide.
Hey, Miss Brady, can I watch the lunch?
No.
Wait, can we watch the what?
Shut up.
Wait, what did you have?
No, shut up.
Okay, I want you guys to try the next slide on your own. Try the next. We are struggling, some of us. Some of them are fine, some of them are a little bit harder. What goes into 5x squared minus 20? Is x squared minus 4 a difference of perfect squares? Yes, they both multiply and you can use one of each sign. So we have 5 times x plus 2, x minus 2. What goes into 4 and 16?
4.
So that's a squared b squared minus 4. So, is a squared a perfect square?
Yes.
Is b squared a perfect square?
Yes.
Is 4 a perfect square?
Yes.
Can we use one of each sign?
Yes.
So we have a difference of perfect squares, so that's 4 times ab plus 2, ab minus 2. All right. Is 4 over 25 a perfect square? What times what is 4?
4.
Over 5. So 2/5 x and 2/5 x. And is 9 a perfect square?
Yes.
3 times 3, right? Can we use, I'm not taking x out of anything. I'm not taking it out though, that's a GCF though.
Yeah, it's a GC.
That's not a GCF. A 9 does not have an x. You can't take an x out. Okay. What times what makes a negative?
A negative and a positive.
One of each. So I have 2/5 x minus 3, 2/5 x plus 3.
I'm like,
Why? 2 times 2 is 4. 5 times 5 is
oh.
x times x is. Okay?
Yeah.
Thank you. All right, what goes into this one? Okay, do we have perfect squares? Is it a difference?
No.
So can we have one of each sign? No, so we're stuck here. This is not prime. Why is this not prime?
Because you have stuff that goes into both of them.
You took something out, right? You have a GCF. That means you factored something out from the beginning, right? So if you can't do anything, that's when it's prime. Meaning you can only take a 1 out, but we could take a 3 out. So we're good. All right, let me get you guys your homework.